Hello students, welcome back. Now we are going to talk about analog inputs handling using Arduino. So we know that there are 6 analog pins. Every analog pin is attached with a 10-bit ADC. That means we can have 2 raised to power 10, that means 1024 possible outputs, which are the inputs of analog pins. These outputs will be decimal numbers from 0 to 1023. That means if you feed any voltage between 0 to 5 volt at analog pins, they will be converted into one of these decimal numbers. We are going to use the function analog read and program. So what we are going to do, we will use one of the pins. We will attach some switch or potentiometer or anything that can provide us the analog voltage, and we control the LED based on the analog signal received. So we go to the components and this time we search for a potentiometer. When you look for the potentiometer, please make sure that it is an active potentiometer. So we take it and we place it somewhere. Okay. Now one end of the potentiometer will be connected to 5 volt and another to ground. This output will go to one of the analog pins. In Arduino, the pin names are A0, A1 till A5. But in Proteus, these are AD0, AD1. So in the schematic, I have to mention the name as per the schematic. So we take one port, rotate it and attach it here and double click and say AD1, AD0, anything that you want to take. So basically I am taking A1 here. Now we come to the coding part. I am saying pin mode A1, that is my input. Now I will declare one integer, let us say y, and we are going to say that y is equal to analog read of pin number A1. In the programming, you have to stick with the Arduino nomenclature. Then we say if y, what is the range of y? Y is between 0 to 1023. If y is greater than 600, in that case the LED is high, else the LED is low. Simple code, simple logic. We save it and we run our program. So now what we can observe, if I bring this down, the LED is off, and if I bring it up after a certain threshold, the value is high. We don't know what is the value that is coming, but we are able to observe that at the lower values, the LED is off, and at the higher values, the LED is on. How do we read that the number coming from this analog pin is more than 600 or less than 600? For that, we need the concept of serial monitor. What is serial monitor? We go to these terminals and we select a virtual terminal. First of all, we stop the simulation and we take the virtual terminal. A virtual terminal is having receiver and transmitter. We are going to connect our Arduino receiver and transmitter in the cross-coupled way. What is cross-coupled? That means the transmitter of Arduino will go to receiver of virtual terminal and receiver will go to transmitter. So this is TXD, that means transmitter goes to receiver, and RXD, that means receiver goes to transmitter. Come to the coding part. We are going to first of all say serial.begin, that means start the serial communication at this rate. Then once we are reading this value, we say serial.print ln means new line, Serial.println means print on the serial monitor with a new line. And what do we want to print? We want to print the value of y. After printing, wait for some time. So we say delay of 1000. We save it, and now we come to the schematic and we run the simulation. We can see that the value is 614, which is more than 600. That is why the LED is on. If I bring it down, the value is 512, which is less than 600. The LED is off. If I bring it further down, now the value is 307, less than 600. If I bring it up, the value is 614, more than 600, 717. And we can go to the maxima, which is 922, which is achievable here. So you can see that now we are able to handle analog inputs and control digital devices using them. So students, we have done things which are good to get started, but now we will focus on the programming. We'll learn the different programming concepts one by one with examples in the next videos. Keep learning. Thank you.